vaccine or the antigen that acts as a field virus. If you do the antigen that acts as a vaccine, it tells you if you made the proper vaccination program, you have immunized the correct number of birds that are responding correctly to them. You can do the field antigen that kind of tells you the protection, and you can set your standards of what you want for your titers, and if they fall below those standards, then you can boost them. Well, with the HVT, it's a little bit different. You do get HI titers. They're usually lower than with inactivated vaccines, but you still get protection. And they're really effective at assessing this protection as long as you realize that the titers are going to be lower. But also you can do a little different process. You can really assess the vaccine replication in the birds, either by looking for the vector and its insert in feather follicles or in the spleen to tell you, hey, the HVT replicated, expressed its antigen, and therefore the immune system is responding to it. Or you can actually use the new H5 ELISA test to help you assess the antibody production in the field. And there is some additional field validation that's ongoing and needs to be done for that. And the final part is the surveillance of vaccinated populations to kind of look for the field virus that helps you in your assessment of how effective is the program and does it need to be changed. So it identifies those active infections to determine if there's any infections in vaccinated flocks or their products. And you usually use a susceptible population. That's the ones that were missed during vaccination or didn't mount an immune response. That's the daily mortality or sick birds within that population or bucket surveillance. And you can supplement that by environmental samples and use the real-time, very sensitive real-time PCR, which in the United States we use pools of up to 11 swabs in our flock sampling for our non-vaccinated flocks. If you do find viruses in vaccinated populations, then you can do genetic and antigenic studies to determine is that virus an escape virus or has developed resistance to the vaccine or not. If there is changes, then vaccine seed strains may need to be updated. And of course there's the serial surveillance, and this is sometimes just called DIVA. This detects antibodies not the virus, so it really doesn't assess active viral infection. It really just looks as a window of did you have any infections in the past. And in this case, that data is not as helpful in determining risk as it's data to help you make decisions in the process of should you change the vaccination program, should you update vaccines, or should you change the population or geographic area. So those are just part of the decision process in vaccine stewardship. So in conclusion, the H5N1, for example, goose guangdong high path lineage is really unique and not typical of all these emergent high path viruses. There's been a huge change in the epidemiology of these goose guangdong viruses, and it's really created a global panzootic with devastating infections not only in poultry, but diverse wild birds and mammals, domestic birds and mammals, as well as humans on 6 different continents. In 2024, we really, the first part of the year, saw a decline in the number of cases in poultry, other domestic birds, wild birds, throughout that summer timeline. But currently, at least the pace began to pick up about October, November, with the number of deaths and culling of poultry, to make us question, are we on the verge of a 6th wave of the goose guangdong virus? Egypt became a goose guangdong infected endemic country in 2006, and has had at least 2 introductions of high path AI unique clades, and these then have mutated within Egypt itself to generate 6 different hemagglutinin subclades. Vaccination has become the primary method for prevention and control of high path AI in Egypt, and WOA does support poultry vaccinations as a tool under specific conditions. Vaccines are very helpful in increasing resistance to high-path AI infection, reduces the replication, prevents illness and death, prevents and reduces environmental contamination and transmission, prevents and reduces the spread between premises of this virus, and maintains livelihoods and food security. An effective program requires you use high-quality, potent vaccines, antigenically relevant vaccine seed strains, especially the inactivated vaccines, having a proper vaccination program with an adequate number of vaccinations, monitor the population for protective immunity, and survey vaccinated populations to find those infections. This close antigenic match is really needed for inactivated vaccines to be effective, and such vaccines may need frequent seed strain updates to protect against diverging field viruses. The recombinant HVT does give you some advantages under certain conditions, broad protection that's more broad than inactivated vaccines, and it gives you multiple arms of the immune system that provides that protection. It overcomes maternal immunity and is allowing one-day hatchery administration. When you combine HVT in a prime boost situation with an inactivated or non-replicating vaccine as the boost, it is a very cost-effective and has the broadest protection against field viruses in chickens.
Okay.
Assessment of this vaccination is possible by monitoring HI titers or ELISA H5 titers, as well as looking for detection of the recombinant HVT in feather follicles or in spleen. And with that, I thank you for your time.